Welcome to the Create Meaningful Models Using Lidar and Surfer webinar. My name is Rachel and I will be the presenter for today's webinar. I'm here today to show you some ways for how to leverage the Surfer Lidar processing and visualization tools to generate point cloud maps and to post-process Lidar data to create 3D surface models in Surfer. After the discussion of each topic, I will stop for a few minutes to answer any questions. You can send your questions to the webinar host, which today is Drew, via the Q&A function located on the Zoom toolbar at any time. Type in your question and it will be sent to Drew, who will either answer it or forward it to me. Please use the Q&A function rather than the chat. This will allow the host to ensure we see all questions in a timely manner. Feel free to send in all of your questions. If we don't have time to answer them during the webinar, we will answer them via email once the webinar is complete. This webinar is being recorded. Later this week, we will post the recording along with the data used in this webinar. We'll send you each a link when it's posted so you can test out the examples for yourself. Okay. So today I'm going to be walking everyone through some workflows on visualizing and processing LiDAR data in Surfer using Surfer's LiDAR processing and visualization tools. Specifically, I will be focusing today's presentation on creating and viewing point clouds from LAS and LAZ files in Surfer, filtering using predefined ASPRS classifications, editing point clouds and reclassifying point clouds, creating 3D surface models from LiDAR and then viewing them in Surfer's 3D view window, and using the LiDAR data with different data types. And lastly, we will look at exporting your LiDAR models from the 3D view. So before we jump into using LiDAR data in Surfer, I wanted to touch on what LiDAR is for those that are not as familiar and give you some background on this type of geospatial technology. LiDAR is a remote sensing method that produces massive point cloud data sets that can be managed, visualized, and analyzed using Surfer. These point clouds can have millions of data points, which we'll see in this presentation. LiDAR is short for light detection and ranging, and it uses light in the form of pulsed laser to measure ranges or distances to a target. A LiDAR sensor fires off beams of laser light and then measures how long it takes for the light to return to the sensor. The basic mechanism is known as time of flight measurement, in which a laser beam is emitted towards an object, reflected off the object, and then collected in a sensor located within the LiDAR module. So the technology is very similar to how radar and sonar function. This data is used to accurately map out our environment, and after the data is collected by the LiDAR module and sensor, it is typically processed into an LAS or LAZ file. And this is where Surfer comes into play. Okay, so now that we have covered a basic background for LiDAR, let's move on to some examples so you can see how to work with this type of data in Surfer. First, I'm going to start out with creating a point cloud layer, which is the way Surfer renders these massive point clouds. So in a fresh plot document, let's start out with importing an LAS file that was downloaded from the USGS's 3DEP program. We have a couple of LAS files for an area in Golden, Colorado, which is where we are based out of. So in the ribbon, I'm going to click Home, New Map, Specialty, Point Cloud. I'm going to pick one of our golden LAS files and click Open. Now we see the Import Points dialog. This is the filter command center for LiDAR data. At the top of the dialog, you will see the entire number of points for this LiDAR data set. So here we have over 1 million points just in this one data set. For this first point cloud layer, I'm going to import the file in its entirety, so all 11 million plus points. And I will discuss some filtering options shortly. So from here, we can click OK to create the point cloud layer in Surfer. You can now see the point cloud layer. I'm going to zoom in. And this is rendered using elevation and the default color map. Again, this map type is merely showing the point locations of the LiDAR data returns. It is possible to render a point cloud using other settings. So select the layer in the Contents window, and you go to the Properties window, the General tab. Under Appearance and View By, you can view by intensity, return number, or render by classification. These different rendering methods vary per what's actually in the LAS or LAZ files. For this example, I'm going to be creating a continuous 3D surface from the data, so I'm going to set the setting back to elevation. It's always good to take a look at the point cloud and see how it's visualized in the Surfer's 3D view. I like to do this with all LAS, LAZ files for the first time, so I can see if there are any things like noise, extra inadvertent data points, or anything that's appearing that isn't as expected. So to launch the 3D view, you can select the map object in the Contents window and click the View tab in the Property window, click 3D View. So as I rotate the point cloud around the 3D viewer, you can clearly see that this file does have some noise, which are the data, the blue dots, floating around the main point cloud map. You can even see how this file might look if we created a 3D surface map here. So I'm going to go back to the plot window and delete this map and then re-import the data, but filtering out for this noise. So close the 3D view and delete the map. And we're going to re-import the same file again. So again, home, new map, specialty, point cloud. I'm going to pick the same file, open, and we're going to spend some more time on the import points dialog. So I mostly want to focus on what the ground looks like of this data set. So I want to include only the ground classification. I'm going to turn off all of the other classifications by checking the checkbox next to classification and then select just the ground points. So once those are selected, I can click OK and wait for Surfer to load the point cloud layer. Great. And again, let's check how this looks like in the 3D view to see if most of those points were removed. Okay, so this model looks a lot better. We don't have any of those points floating in the air, and we can see a better 3D model already just with our point cloud. Okay. Going back to the main plot window, I have another data set that corresponds to this LAS file, again in golden. And the area that I want to create extends into this other LAS file. I'm going to add another point cloud layer to the existing map frame by using the same steps I did a few minutes ago, including using only the ground returns. So to add a layer to a map, you can have your map selected and click Add to Map Layer, and we'll select point cloud again. And now I'm going to select the other side of my data set. And again, filtering out for classification and selecting the ground classification. Click OK. I do want to update my map extents to include this new data set. Zoom in. Okay, so I have two sides of golden here. So now that I have both LAZ files loaded into the same map frame, I'm going to use Surfer's point cloud tools to extract the portions of the point clouds that I want to continue using which will be more of the central area of the map. So in this case, I'm going to be omitting this chunk over here. To extract this portion of the point cloud, first I'll need to make sure that I have the correct point cloud layer selected. So if you select your layers in the contents window, you can see these blue dots appear for the layer that's selected. You can also turn off the layers to make sure you have the correct one selected. So I'm going to be working with this top one. And you will also notice that when these layers are selected, we are in the point cloud tab of the ribbon, and it opens up some more options to us. So to extract the portion that I want from this point cloud, I'm going to be using the rectangle point selection tool. When I use this tool, you can see that my mouse turns into crosshairs. So in this case, I'm going to select the area that I want to continue using. Let's see. Okay. So to select, you just click, drag, and then release to unselect. From here, and once your points are selected, I can use the crop to selection tool. And it's removed those data points. Now I can click deselect all to remove that selection. So now that I've extracted the data, I'm going to export the point cloud layer to a new LAS file by clicking Point Cloud, Features, Export LAS, LAZ. We have the Export Point Cloud dialog pops up, and the only thing I really need to do in this window is rename my LAS. So I'm going to shorten it a bit and name it Cropped. I'm going to click OK. So now that I have this new LAS file created, I can combine these two areas to create a 3D surface. To create the 3D surface, both LAS files need to be gridded and then mosaic together. This can easily be done by clicking Grids, New Grid, Grid Data. In the Grid Data Select Data dialog, we're first going to select the cropped LAZ that we just created, or LAS. This opens up the Lidar Import Filtering dialog. So I'm going to filter out everything except the ground returns by clicking the Clear All button towards the bottom, and then checking ground. So you can see our points are updated when this selection has been made also. And click OK. And for our gridding method, we're going to stick with kriging and skip to end. So on the last page, I'm going to change the resolution so we can get some better detail in the surface. For this specific data set, I'm going to set the spacing to 4 for both X and Y direction. But if you have LiDAR data of your own, you can experiment with your spacing to see what produces the best results. So now that the spacing has been set, I'm going to add this grid layer to my current map, and I'm going to add it as a color relief layer. Click Finish. Okay. And now we can see that that color relief layer has been added. We're going to go ahead and repeat the same steps for the other side of the map. So again, that was grids, new grid, grid data, and selecting the unedited LAS file. We're going to clear all the classifications and select just the ground classification. Okay, similar with the last one, I'm going to change the spacing to get the same resolution. And I'm going to add this grid as a layer to my map, and it's a color relief layer. Okay. So we can see the new color relief layer. Now to finish the model up, we need to now stitch these two grids together. I'm going to turn off my point clouds so we can better see the color relief. And how we stitch grids in Surfer is we mosaic them. To do this, we go back to the ribbon, and click grids, and resize mosaic. I'm going to select my cropped grid, and then I'm going to add my west grid. Okay, when you select the different grid extents, you can see which layer are represented in your new map. So the only other thing I have to do in this window is select my output name and then the add to map. So I'm going to name this combined. And we're going to add it to the same map again as a color relief layer. Click OK. Okay, I'm going to move up the color relief layer and we can see that those two grids have been stitched together nicely. So now to finish up this model, and a good way to bring this more into the real world is to use the download online maps option to add some real world imagery. So to do this, you would like to go back to the ribbon, home, add to map, base from server. This opens the download online maps dialog. So I'm going to select US imagery, NAPE imagery. And since we're in Colorado, I'm going to select the Colorado folder and image. And I do want to note that these data sources are on external servers and their download time can vary and sometimes might be unresponsive. This is something not related to Surfer, but the external servers. So instead of waiting and for the sake of time, I'm going to back out of this dialog and show an example that I saved earlier. So this is all of those same maps and layers, but with that surface image placed on top. And in the 3D view, we can see a pretty good surface model of the golden area. And again, this was created by using our Lidar point cloud, creating grids from the point cloud, mosaicing or combining those grids, and then overlaying a imagery picture on top of the combined grid. So now that we have created and viewed the point cloud data, created a 3D service model, filtered the data, and edited the point cloud, I would like to open it up for any questions that might have come up during this first example. So I have one question. When you create the new LAS, do all the classification data from the original file go with it, or just the classification ground you selected when creating the map? That's a good question. So when we filter the data, and save out the LAS, all of that data is still contained in that file. So the filtering is a visualization tool. If you want to remove the data points, that's when we cropped the data points and then resaved as an LAS. So when you go to grid the data, it is still necessary to choose the ground classification to just show those ground points. So another question, is there a way to force the grid cell size to an explicit size? And so there are two ways to edit your grid cell size, which was the spacing and the nodes. So if you're trying to get, it can be hard to get a rounded spacing size, so meters, for example, because the spacing is based off of whole nodes. Okay, so thank you for the great questions. If there are, again, any unanswered questions at the end of the presentation, me and Drew will do our best to get them all answered, and we'll follow up via email if we missed any. On to the next example. I'm going to open a new plot document. And this time we're going to show you another example using LiDAR data in Surfer to create a detailed model. Again, this data was downloaded from the 3DEP USGS program, and this specific example is an LAZ file located around the Golden Gate Bridge and the surrounding area. So I'm going to go through the same steps as before to create my point cloud layer. Again, home, new map, specialty, point cloud, and I'm going to select my Golden Gate data. So in this instance, we're going to open up all of the points. So we're not going to do any classification filtering right now. We can wait for Surfer to load this data set. Okay. So as I zoom in on the data, the point cloud layer that Surfer just created, you can clearly see what's probably a man-made object, and in this case, the Golden Gate Bridge. So just like the other example, we're going to look at this in 3D view to see what we're working with. I'm going to rotate this around to get a better view. And zoom in a bit. Okay, so in the 3D view, you can also change how your data is visualized a little bit. You can select your point cloud layer and change your point size in the general tab of the properties window. So I'm going to decrease this. You can see a more clearly defined bridge here. Okay, going to go back to the main plot with this point cloud data. So now that I can clearly see that this is the bridge and we have some ground returns up here in the corner, I'm going to access the LiDAR point cloud tools again to reclassify the bridge data. So click on your point cloud layer and it brings you to the point cloud tab of the ribbon. And instead of using the rectangle point selection, we'll be using polygon. You click the polygon option, your mouse turns into crosshairs, and you can start outlining the bridge. And I'm just going to do a rough outline, but of course, if this was your data, you'd want to get as detailed as possible. Okay, and then when you're done selecting on your last point, you can just double click, and you can see the selection that we just made with the polygon point selection tool. So now that the bridge has been selected, we can reclassify these by going to point cloud, classify, reclassify, and then scroll down, and we're going to change this to a building. Okay, so all of the selected points have been reclassified, and now I can deselect by going to point selection, deselect all. So now all of the point cloud data is back, and everything that was previously selected is now classified as the building. So next, I want to remove some of that open water by using the rectangle point selection tool that we used in the first example. So again, in the ribbon, you can click point cloud, point selection, rectangle, and drag a box around the points I don't want to retain. Okay. And then from here, we can click Remove Selected Points. So this is a little bit different from the first example when we instead chose to crop to selection. But here we're going to remove the selected points and remove all of that extra water. When that is done, you can press Deselect All. And now we're going to go ahead and export these points out so we can work with a smaller file. So I'm going to click Point Cloud, Features, Export LAS, LAZ. I'm going to change the name. And save. Great. So now that this export is completed, I'm going to create a new plot and add the newly exported LAS or LAZ as a point cloud. Like the first example, I'm going to grid the data to create a surface for the ground returns. So in a new plot, I'm going to go ahead and grid the data. And so I used a slightly different method to open the grid data dialog that I want to highlight, which was home, grid data, grid data. And I'm going to select my cropped Golden Gate data. And then here for the classification, we just want to look at the ground returns. So we're going to clear all and select ground. Okay, and we'll stick with kriging as our gridding method. Skip to end. And I'm going to decrease the spacing just to get a little bit better resolution to about half. Okay, we're going to add this grid as a new map because we don't have any maps. And instead of a color relief, we'll go ahead and we'll do a contour map. Great. I'll zoom in again. Okay, so you'll notice that the bridge is not included and our spatial extents of our map is much smaller. This is because we classified just for the ground data, and this is what was considered ground data from our point cloud data set. So you may notice that we actually have some interesting data out here. This would be the water and kind of an artifact of our point cloud data. And we don't want this, so we can remove it by adding a polygon to the map and then assigning no data to these water areas. So to do this, I'm going to make sure my map is selected. I'm going to click Home, Add to Map, Base. And I'm going to select a no data polygon that I created earlier just for the sake of time. So this base layer has been added. We can turn off the previous contour map to see those extents. So now that it's been added, we can assign no data to these water areas with the artifacts by clicking Grids, Edit, Assign No Data. So our input grid is going to be the cropped contour layer that we have. And the no data polygon is going to be our no data polygon. For this example, I'm going to assign no data inside our polygon. I'm going to change the name just to no data. We're going to add this as to our same map. And again, as color relief. Great. So you can see our color relief map has been added, and everything that was inside of that polygon I created was assigned no data. From here in the properties window, you can click on the general tab, and you can turn the opacity down on your no data section. We can go ahead and turn off the contour map and the no polygon layer. So if you would like, at this point, you could choose to add another NAPE image to give it some real-world detail by using the Download Online Maps tool that we used for the previous example. But for the sake of time, I won't be doing it with this example. So from here, though, we can launch the 3D viewer. And we can see our ground example. In the 3D viewer, you can also add water by clicking on Environment. And then in the General tab of the Properties window, check Water. And you can adjust this water level. Okay. So now that we have a 3D surface, let's go ahead and add in the bridge data. So first, since I'm adding the bridge to my existing map frame, I need to make sure the map is selected by clicking either anywhere in the plot or selecting the map. In the ribbon, I'll do Home, Add to Map Point Cloud, like we've been doing. And I'm going to select that cropped point cloud data. So in this instance, I only want to see the bridge, and we reclassified the bridge as building just a few minutes ago. So we'll turn off all of their classifications and scroll down just a little bit to select building. And then you can click OK. And we'll want to adjust the extents so we get the full length of the bridge. Okay, so we can see that the bridge has been added. Let's see what this looks like in the 3D view. And again, you can update the point size of your point cloud data by clicking your layer data and adjusting your point size. And in the environment section, we'll want to update our water level, be a little bit more accurate. And there we have a 3D model using point cloud data and gridding of the Golden Gate Bridge and nearby area. Okay. Okay, so I'd like to open it back up to any questions that may have come up during this example. Please send them over to our webinar host, Drew. Okay, so one question, is polygon selection in the point selection option always for points to retain? Similar to the rectangle option, you can choose to either crop to your selection or remove points within your selection. Another question, can you clean up the yellow points under the bridge? You can. This would, as you can see, these yellow points are kind of on the outline of our bridge data. So this is just something from me not making the most accurate polygon. So if you wanted to clean up all these points, you would go back in to create a more accurate polygon to reclassify those points. Okay, looks like that's it for now. Please feel free to keep sending in those questions. So our last section today, and while we're still in the 3D view, I wanted to take the time to cover how we can use your LiDAR data with some other data types in Surfer, namely 3D points and 3D polylines. So something we have added in recent updates is the ability to digitize points in the 3D view. So to digitize these 3D points, I'm going to go back up to the ribbon in the 3D view. Under Tools, I'm going to click 3D Digitize. So again, your mouse will turn into crosshairs, and you can begin clicking on your point cloud or any other 3D surface. So I'm just going to click certain points. And when I click a point, we have a digitized coordinates text box show up, and this will preserve points that we create as we click. Since this is a 3D cloud or point cloud, I'm going to be adjusting my angle to make sure I'm hitting the points I would want or near. Okay. Okay, for now, let's just stick with those points, but you can keep clicking and selecting. This can be really handy if you're trying to pick out future sample sites or just getting z-values off of specific points. So you can save out your digitized coordinates, File, Save As, and you can save them as a .dat or a .bln. And for this example, I'm going to save them as a .dat, and label them points. Okay, so you can also use these points in the plot window. For example, if you wanted to convert these to a 3D polyline, you would go back to the plot window. You can close out your digitized coordinates, but you can go back to the plot window, and in your same map, you can add a new layer. And in this case, we're going to be adding a base from data. So in the dialog, you'll want to select the .dat file that you just created for your points and click Open. Okay, so as you notice, this came in as points, which makes sense. We just created 3 points in the 3D view. But if you wanted to convert these to a 3D polyline, all you need to do is highlight all of your points by clicking and holding Shift. Then you can right-click, choose Change to 3D Polyline. This opens up a Points to 3D Polyline dialog, which is asking how you'd want to connect your points, and we're just going to do list order, but you can also do sorted attribute values, and where it wants to copy the Z coordinate info from, which in our case is column C. So we're going to click OK. And if you zoom in, you can see these points have been connected, and it's considered a 3D polyline in our base vector. So to see what this looks like in our 3D view, oops, it's a little hard to see, and to get out of the 3D digitize, you can just hit trackball. But you can see our 3D line has been connected along our bridge. So now that we're back in the 3D view, the last thing I wanted to cover really quickly was our exporting options from the 3D view. So your options are to copy to clipboard, which will copy your current view to the clipboard so you can paste it in whichever application you choose, like Word or PowerPoint. The next option is to export the image. And with this, you can export it to any of the following image file types, and there are many to choose from. So this is great for saving out many images or different views. And then the last thing that we've added in recent updates is the ability to export the 3D. And for exporting 3D, we have 2 options, the 3D PDF and WRL VRML 3D vector model. And I do want to note that the 3D PDF file can be opened just with Adobe Acrobat. So these are great options for if you need to share your 3D model with someone who doesn't have Surfer. Okay, so that sums up the presentation. And with that, I would like to open it up to any other questions. I do have a question. Can you go over the interpolation again? For the sake of time, we will go ahead and send the video link at the end of this week so you can watch this video at a pace that's comfortable to you. We'll also include all of the data that we use so you can walk through with the same data that's in the video. So another question, is it possible to filter buildings in general? Say, remove isolated barn to reveal terrain surface. So you can filter for the building classification, and you can reclassify again with the selection tool, and then you can grid that data. Another question, is this tool primarily suited for topography, or can you use it to produce other features from the data? So LiDAR is just measuring the distance of that light bouncing off a surface, so you can use it to measure any surface data. So buildings, really any surface data, terrain. It's well suited for topography, but it can be used for vegetation, things like that as well. Okay, so it appears that that's it for questions for now. And that concludes my presentation of the Create Meaningful Models Using LiDAR in Surfer webinar. Hopefully everyone found the information I covered useful today. And if you have any additional questions on what was covered today or anything else Surfer related, now that the webinar is concluded, you can call our technical support phone line or email questions to support@goldensoftware.com or surfersupport@goldensoftware.com. Again, a recording of this webinar will be posted shortly on our website. And as always, thank you very much for your time.